All right, we're coming back to the same form for the absolute value function that we started with in our starter. G of x equals a times the absolute value x minus h plus k. That's called the vertex form of the absolute value, because we can read the vertex right from the equation. The vertex is h comma k. Now, I want you to notice that that vertex happens when the inside of the absolute value is equal to 0. So at x equals h is the x coordinate of the vertex. H is the x coordinate of the vertex, and when we plug in h, we get a y value of 0. So hk is the vertex. Absolute value functions can be written in vertex form, and their graphs will be symmetric across the vertical line through the vertex, that line x equal h. It's our symmetry line. All right, we're going to do an example. We're going to take a function, f of x equals the absolute value of x plus 2 take away 3, and we're going to graph that. We're going to make a table of values. It's really x minus negative 2 inside the absolute value, because remember plus 2 is the same as subtracting a negative 2, and subtracting 3 is the same as adding negative 3. So if we look at it that way, we see that h is negative 2. There's our x minus h plus our k. So h is negative 2, k is negative 3. So our vertex should be at negative 2, negative 3. Let's make a table and test that out. So we're going to plug in x equals negative 4. And if we do that, we have the absolute value of negative 4 plus 2 take away 3. Absolute value of negative 2 take away 3. That's 2 take away 3, which is negative 1. Pause the video, fill in the rest of the table. All right, once we've got the table filled out, we're going to plot the points. We've got negative 4, negative 1, negative 3, negative 4, negative 1, negative 3, negative 2, negative 2, negative 3. Then that's our turning point, because notice now we're going back up. Negative 1, negative 2, 0, negative 1, 1, 0, 2, 1. Our function f is this V shape right here. So there's our function f. Now we're going to fill in the table for the function g. So for the function g, absolute value of 2x plus 2 minus 3. This is not vertex form because that 2 is inside with the x, not out in front of the absolute value. So it's not really vertex form, but we can still graph it. It'll still be a V shape. So we're going to plug in x equals negative 2. 2 times negative 2 is negative 4. And negative 4 plus 2 that's going to be 2 take away 3, which is negative 1. Notice what's happening is we're chopping the x values in half. That 2 that's inside with the x is causing a vertical, a horizontal shrink. When it's inside with the x, it's going to be a horizontal change, and it's a horizontal shrink. I'm going to pause the video. You guys can plug in the next and find the rest of the table of values. Notice when you plugged in negative 1.5, we got 2 times negative 1.5, which is 2 times negative 1.5, which is negative 3. Negative 3 plus 2 is negative 1. The absolute value of negative 1 is 1. 1 take away 3 is negative 2. So we get a y value of negative 2. If we plot all those points, we have negative 2, negative 1. We have negative 1.5, negative 2. We have negative 1, negative 3. We have negative 1/2, negative 2. 0, negative 1, 1/2 and 0, 1 and 1. We graph that V shape. Notice on this one, what we've done is we've taken our x values and we've cut them in half. So negative 2, negative 1 is now whoops, -2, -3, sorry, -2, -3 is now -1, -3. We've cut the x values in half, so it's a horizontal shrink. Right? Let's fill in the rest of the information in the blanks here. Now, notice that for the function f, the vertex is -2, -3. It's symmetric across the line x equals -2, that vertical line right through the vertex. Notice that we can rewrite the function g as f of 2x, we just replace the x with a 2x. So it's in the form f of ax, where a is 2. That's causing a horizontal shrink by a factor of 1/2.